Thank you all for attending today and yesterday. Our anchor for the DinoFest relay of talks, bringing us home for the win, is ReBecca Hunt Foster, who's the monument paleontologist at Dinosaur National Monument. And we'll be talking about why it's a cornerstone for late Jurassic dinosaur paleobiology.
All right, I appreciate y'all hanging in there with me and coming to this last talk. I'll try not to keep you too long, but I appreciate you being here. So who's been to Dinosaur National Monument? Oh, right. Yeah, that's what I like to see. Okay. So please come back if you've already been, and if you haven't been, please come and see us. Dinosaur National Monument, of course, is very well known for its dinosaur fossils, hence the name. And I'm looking forward to telling you a little bit more about it today. Dinosaur National Monument is located on Ute land, and we like to recognize that that is their tribal land. And we also work with 36 other federally recognized tribes, just knowing that a lot of different people are connected to that environment that we're working in. So as far as National Park Service units go, we all love our National Park Service units, but there's only been 18 that have been set aside to preserve and protect fossils. So that's not very many in the grand scheme of things. So here's a list there of those 18 parks. And so those are just the ones that were specifically set aside to protect fossils. But of all the different national park units, these are the national park units that preserve dinosaur fossils. So you'll notice that not all of those were set aside originally to protect the fossils. They may have been set aside because they're really cool geologically, like Big Bend or something like that. But there are a lot of fossils, mostly crowded around on the Colorado Plateau, that preserve these dinosaur fossils. And this is what the geologic map looks like for Dinosaur National Monument. We've got this beautiful tie-dye map of different units. We have 23 different geologic units, so we're right up there with Grand Canyon in the number of different geologic units we have represented. Our park sits on the Utah and Colorado border. So we have the Utah side of the park over here, Colorado over here. The Colorado side was a later expansion, but most of the park that's exposed actually preserves Paleozoic rocks. So most of the rocks in our park are older than dinosaurs. But of course, Dinosaur National Monument is known for its dinosaurs. So I'm here today to talk to you about the dinosaurs that are found in the historic Carnegie Quarry, which is located over here on the Utah side of the park in the Morrison Formation. So the Morrison Formation, as we know, contrary to what Tyler said yesterday, is the best unit in the Mesozoic. We love the late Jurassic. Late Jurassic is awesome. And there's lots of great dinosaurs, and a lot of great paleontology work has taken place in the Morrison Formation. The Morrison Formation ranges all the way up from Canada, all the way down to New Mexico. It's usually these kind of beautiful green and red rocks, maybe some tan in there. We get a lot of mudstones like this and a lot of sandstones. And these are what all of our fossils are preserved in. So I'm going to tell you a little bit about Dinosaur National Monument and how it came to be and why it's there and why it's so important. So the Carnegie Museum, back when it was brand new out in Pittsburgh, had been working in Wyoming on dinosaur fossils. And Wyoming's starting to get crowded at the early 1900s. Lots of people are out there digging fossils. And they had dug up a really beautiful Diplodocus and named it after Andrew Carnegie, which is smart, always name things after the guy that's paying for stuff. And he was like, this is great, go find me more. But they were tired of working in Wyoming, and they're like, it's getting a little crowded. So they had been told by some folks at the American Museum, hey, go down to the Uinta Basin in northeastern Utah, and we're starting to find dinosaur fossils down there. Uinta Basin was really well known for its mammal fossils, but wasn't really well known for its dinosaur fossils yet. A few had been found, but nothing really notable. So in 1908, Holland sends Earl Douglas out to the Uinta Basin. Earl Douglas is a mammal paleontologist, and he's sent off to look for dinosaurs. I'm sure he was grumbling under his breath a little bit about it, but he gets out there and he finds some nice fossils. He's like, man, this is great. Okay, we'll come back next year and we'll dig these up and take them back to the museum. This is going to be good. So they come out in 1908, they find these fossils, they're going to come back in 1909, and they come back, somebody took their fossils. So somebody got there before them and took the fossils that they had planned on excavating and so they didn't have what they came for. So they had to start walking around and looking for new things. And as Carrie's talk and Tyler's talk and some of the other talks that we've had today, Natalie's talk, kind of show you, it's a lot of wandering around sometimes. Sometimes we just wander and wander and walk and walk and walk and look for fossils. And so that's what they did. They kind of wandered around the Uinta Basin for almost a month trying to find fossils. And these are excerpts from Earl Douglas's diary. And this is Earl in his awesome little boots here to avoid the snakes, I assume. And he's getting real bummed. You know, it's July, it's hot in the Uinta Basin, he's not finding what he's needing. And you never like to write, you know, the boss man and the money people back, and they're like, no, I'm not really finding anything. So they'll make you come home. You don't want to go home. You want to stay in the field. So he's not finding anything, he's pretty bummed. But this all changes when somebody tips him off and says, hey, go look above the town of Jensen, Utah. There's not very much in Jensen, Utah still to this day. And even back then there wasn't very much beyond the little ford across the river. But so they went up that direction and started looking around. And this is what they found on August 17th of 1909. They found these beautiful series of articulated vertebrae. And he said it was a beautiful sight, just amazing. So he decided, yeah, okay, this looks like a good place. The more they start looking, the more fossils they start finding. He's like, great, we're gonna dig here. So this begins quite the journey, where they work from 1909 to 1922, and then there are crews that work in 23 and 24 as well, excavating fossils. And they remove so many fossils. They remove over 700,000 tons of material. And so this is rock and bone, and keep in mind all this stuff is being hauled out by horses and trains, and it takes quite the wild adventure to get it back to the Carnegie Museum to get these things on display. So they work for a number of years. Earl Douglas moves his family out here, he builds a little cabin, and they all happily live in what becomes Dinosaur National Monument, digging up fossils for a number of years. And they find a bunch of really great stuff. But I'm going to focus today on just a few of those discoveries that help to really inform paleontology and teach us a bunch of new things that we hadn't learned. I mentioned that people had worked there in 23 and 24. The National Museum of Natural History, the Smithsonian, came out in 1923, and they removed this Diplodocus and a Camarasaurus that are now on display in their gallery. So you can see these two beautiful specimens if you visit the Smithsonian. And then the University of Utah came out to dinosaur and dug, and then they had a parade when they brought their fossils back to Salt Lake. They had a full-on parade with Kit and John, the mules, bringing in the trailer full of fossils here. You know, they had like the handshaking and the president's circle, and it was a big old deal. And so even the University of Utah came, and what they removed was this really beautiful Allosaurus. So this Allosaurus, this is what it looked like. I mean, look, it looks like it just laid down and fell asleep. It's just spectacular. And I love these old pictures of it going through the prep process. We have a mount at the Corey building at Dinosaur National Monument, where you can see part of that skeleton. Some of it's a composite with some stuff from Cleveland Lloyd as well. But we have the real skull that the University of Utah dug up on display for people to be able to see. Emily talked about it a little bit yesterday in her talk, and how that factors into some of the research that she does. And so we've had numerous researchers just in the last 4.5 years that I've been there who have come to study this skull because it's such an amazing, spectacular specimen. Clicking too fast, excuse me. So when you come to dinosaur, this is what it looks like today. We have all of these fossils on the rock wall, and this is what you see. We have all these fossils that are still in place. They haven't been removed. And that was kind of the goal, was there were so many fossils, they realized it was important to leave them in place for people to be able to come and see. Because there's not too many places like that in the world where you can go and see dinosaur fossils still in the rock. So that is what is preserved in our Corey building at Dinosaur National Monument. But it's only a fraction of the fossils that have been found. This is a map that Ken Carpenter published that shows all of the other fossils that had been removed. Everything inside the red box is what you can still see today. Everything outside of the red box is what's been removed. All the PAs are things that went to Pittsburgh. CO, the Diplodocus at the Denver Museum, is from Dinosaur National Monument. We have things at the Smithsonian, the ROM, Nebraska. We've got stuff scattered all over the place. They collected so many of these fossils that Carnegie did that they ended up trading them like baseball cards to other museums to trade for fossils that they wanted. So Dinosaur National Monument fossils are everywhere. So who's in the wall? What do we have there? We have 5 different sauropods. We have Diplodocus, Apatosaurus, Camarasaurus, Barosaurus. We have the wonderful herbivores, Stegosaurus, Camptosaurus, Dryosaurus, meat eaters, Torvosaurus, Ceratosaurus, and Allosaurus. Handful of crocodiles, turtles, even little lizard guys, and then these clams. These clams are really the things that helped us to better understand why all these fossils were preserved there. So this is kind of how it breaks down as far as the breaking out of the different types of animals. We have 14 different species representing 124 different individuals. This is just what's still present on the quarry wall today. This doesn't include the material that's been removed. You can see it's pretty heavy in sauropods. Sauropods are large, they take up a lot of the room. But why are all these fossils preserved here? How did they get here? Why do we have them? The key to that is that all these animals were living along a river corridor that had abundant water. We know there was abundant vegetation in this area. These animals are coming here, they're living in the environment, they're happy, and then a drought happens. And how do we know a drought happens? The way we know a drought happens is that all those clams that lived in that river channel all were popped open. And that kind of tells us they're, it's like clam bake. Those poor little things are dying in the water as the water is going down. We know this happened 3 different times. We have 3 different layers in the quarry building, so it's not just one event. It didn't just happen once. We know that it happened over multiple times. And so that's how all these fossils got preserved. So it's actually an invertebrate fossil. It tells us a lot about why all these vertebrates were preserved in one place. So the first fossil I want to tell you about is Apatosaurus louisei. So Apatosaurus was that first fossil that Earl Douglas found in 1909 when he was working at the quarry. So he was found in 1909 and excavated between 1909 and 1910. And it's still it's the best Apatosaurus that's ever been found. Really beautiful specimen, and it's still on display to this day at the Carnegie Museum. They got it on display fast. Which is really remarkable to think about, getting it back to the museum by 1910 and then prepping it out and having it on display by 1915. Really fast. It's fast for today, but it was really fast for back then. And you have to think about poor people like Lou Cogshell here. He's got a little hammer and chisel. He's doing this all manually. In a room with like natural light and like lanterns probably. So it's pretty amazing the work that they were able to do. But they mounted it headless, you'll notice. Old Diplodocus over here, this is a Wyoming Diplodocus. He has a head. But the Apatosaurus, they weren't sure about his head. So on the quarry map, those first 8 fossils that they found are up here. And so this darker purple Apatosaurus is our discovery fossil. This is the holotype of Apatosaurus louisei, which they named after Andrew Carnegie's wife. Another smart move. So, keeping that money coming in. This smaller Apatosaurus was found later. This is a Diplodocus over here. Just don't worry about Diplodocus. But they had found this skull. And you can see these bones are somewhat disarticulated. Probably still had some connective tissue and things holding them together when they got buried. But this skull was found nearby both of these specimens. And there was some discussion about whether or not that skull belonged to the smaller specimen or the holotype. So Holland presented at a conference in either 1914 or 1915, saying that he believed this really beautiful Apatosaurus skull, first of its kind at the time, probably belonged to this holotype specimen. And at that same conference was his Henry Osborn. Now keep in mind that Holland wasn't exactly a friendly, nice guy. He was kind of a bulldog too, but Osborn was just as obnoxious. And so you have these 2 really obnoxious guys kind of going at each other, and like Osborn threatened Holland and was like, I will ruin your career if you put that thing on the end of the skeleton, because that is not the right skull. And they like got into it. And because the reason they were so like, nitpicky at each other is that Osborn had already had this skull based on a Camarasaurus sculpted and put on the end of his display at the American Museum. And he didn't want anybody contradicting him and saying that their discovery wasn't right. So he threatened to ruin Holland's career if he put this skull up. So Holland backed off, which really blows my mind because Holland was like, kind of rough and tumble himself. So Holland kind of backs off, and so this skeleton sits headless in the exhibits at the Carnegie Museum until the 30s, with this skull just off in collections. And so after Holland died, they were like, oh good, he's dead now. He won't get upset if we put a skull on the end of it. So they put a skull on a Camarasaurus, which isn't the right head. But they were like, oh, it'll look like the American Museum, so we must be right, because the American Museum, they're the only ones that can be right. So in 1934, they put this doofy head of Camarasaurus, which isn't even the right dinosaur, onto this thing's neck. It wasn't until the late 1970s that paleontologists recognized that that was the wrong head on the end of this thing. And after studying meticulous field notes, museum notes, all the things that Carrie and Natalie were talking about being so important, all of that past documentation proved that Holland actually was correct and that the wrong skull was on there. And so on October 20th of 1979, Jack McIntosh and Dave Berman, they had a paper published on the correct skull of Apatosaurus, and they remounted the correct skull onto the museum exhibit. And I love this picture of Jack McIntosh. Jack McIntosh was a great person, and this just makes me happy. So if you still go to Carnegie today, you can see this exhibit, and now Apatosaurus has her correct head, which is really great. Another specimen, another sauropod, funny enough, that really helped to inform dinosaur paleontology early on was this baby, or this juvenile Camarasaurus. It's still to this day the most complete ceratopsian, I wish. Y'all got me in Cretaceous mode now. It's still the most complete sauropod that's ever been found, whether you're in the Cretaceous or the Jurassic. It's a really beautiful specimen. The only things that were missing are what you see here in red. And this specimen was really helpful at the time because it helped us to understand the posture of these animals. There was still some belief at this time that maybe these guys are dragging their bellies around. They've got this crazy splayed, like doing push-ups or something like a lizard, hanging out in the water to support their weight. And this fossil actually helped to better interpret the way that they would have held their body up and the way that they would have looked. They maybe didn't have racing stripes, but more of a correct posture. So that's another specimen that really helped out. And the one that Brian mentioned yesterday in his talk, this Barosaurus from the Royal Ontario Museum, really beautiful specimen that had just been sitting in boxes. It ended up at 3 different museums, again, trading these things back and forth like bubblegum cards. And when they finally unpacked this thing to put it on exhibit, relatively recently, they actually found this beautiful skin impression from one of the legs that was still in the crate, in the box of fossils that hadn't even been prepared. That nobody knew was laying around. So it was a really important thing, and it's got a really nice, shows the skin texture of what this Barosaur would have looked like in a specific part of the body. So that was another really cool thing because the quarry is actually a sandstone quarry, so it doesn't preserve really fine texture very well. So it's nice to have some sort of skin impression. And then this is kind of my new project that I'm really excited to start working on. I should pick Ellen's brain about this some more. This is our baby Stegosaurus, and it's so cute. Everybody loves Stegosaurus. And our Stegosaurus is about the size of like a Labrador retriever. It's nice and little. And these are the various bones. This was found in the 1970s on the quarry wall and was excavated, and it was described kind of preliminarily in the literature, but nothing else had ever been done with it. It's just been sitting in a drawer ever since then. We don't even know how old this animal is. There are very few stegosaurs in general that we have any juvenile material for, and this is the best represented one. So this summer, I got to take this specimen down to UT Austin and throw it in their amazing CT scanner. And we did some CT scan work to see if we could see any sort of histological data in that, or like Ellen's talk yesterday, where we're looking inside the bone to see if we can figure out how old it is. Since this is such a rare specimen and we really don't have any baby stegosaurs, it's hard to convince people to let us cut them up. So we're trying to look into other techniques and trying to figure out a way around it. But so stay tuned. This is something that maybe someday Randy will have me back and I can talk to you about how old baby Stegosaurus was and how quickly they grew, or didn't. We'll find out. We have a lot of Camarasaurus. Camarasaurus is the most common dinosaur that you get in the Morrison Formation, but it's also the most common dinosaur that we have at Dinosaur National Monument. We had 5 different skulls of Camarasaurus that came from the wall, so it's kind of that Disneyland effect of Dinosaur National Monument where we actually have skull preservation because it's pretty rare. This beautiful superstar Camarasaurus everybody sees when they come to the park, we actually, they removed the outside lower jaw so that they could study the inside of the roof of the mouth, because at that point nobody had been able to tell what the roof of the mouth of Camarasaurus looked like. So this was a specimen that helped them to better understand what sort of the inside of the mouth of a dinosaur like this looks like. Same with this Camarasaurus that's on the opposite end of the wall. And then another thing that dinosaurs really helping us to better understand is that this environment probably wasn't just this big savanna of dry area where these animals are stomping around and it's just dry all the time and everybody looks skinny and miserable. It was probably actually a pretty nice environment. There were probably abundant trees for all these giant sauropods to be eating on, tree ferns, conifers, things like this, no grasses yet. And we're starting to find giant logs. Now, this isn't new information. These logs have been out there for decades and more. The problem is that petrified wood's legal to collect, and people like to pick it up and take it home. But if everybody takes all of this log home, then we don't know how big these trees got. And so that's something that now that we're a little more in tune of, hey, these things can really tell us a lot about the environment, people like Brian and others are really paying attention to where these trees are, going out and seeing them, and then figuring out where they're occurring in the geologic section and how that kind of helps us to piece together the environment that these animals are all living in, because they're not living in a bubble. They've got to be eating something. But it goes beyond even these plants and these trees. Dinosaur National Monument has lots of fossils. We have a lot of microsites. We have crocodiles. We have lots of reptiles, even little tiny geckos and things like that. Turtles, lots and lots of turtles. Amphibians, we have newts and frogs, which is really cool to think about having like these little critters that are living underneath the feet of these dinosaurs in these watery areas. Even early mammals. So we're getting a lot of cool critters, and they're really helping us to better understand not just how the dinosaurs looked and what they were like, but how they fit into their environment and how that all comes together into a bigger picture so that paleo artists and people like Brian can then take that and reconstruct our view of what these past worlds would have looked like and help us to better understand, what it was like 150 million years ago at Dinosaur National Monument. So thank you all so much, and I'm happy to take any questions.
Did they ever determine if the Apatosaurus head belonged to the original one or the smaller one?
They did determine that it belonged to the original one. They had the vertebra that would have attached to the skull, and they actually fit together perfectly. So they're pretty confident that that with the larger specimen. Great question.
The quarry wall sounds really cool. What is like the number one other thing a new visitor to Dinosaur National Monument should do? Because I really want to go this year.
Yeah, the quarry wall is really great. Everybody should definitely see the quarry wall. Some of my favorite things, we have 6-foot tall lizard petroglyphs that are really amazing. 6-foot tall, like Fremont era petroglyphs. Echo Park is really beautiful on the Colorado side of the park, where you can go down to the confluence of the Yampa and the Green Rivers. Really beautiful area. A lot of other petroglyphs, and you see a lot of cool critters in there. So, yeah, you're welcome.
Okay, so how do you in paleontology discern species? How do you define a species, since you can't obviously do the biological species concept?
Well, you know that picture that Natalie had in her talk of people fighting over glue? It's basically like that. It's like a big cage match where you just throw a bunch of paleontologists and walk away. Everybody's going to fight. No one's ever going to agree on things. A lot of people are teasing apart, looking at different little key things on the skeletons. This skeleton maybe looks a little different than this one. It's kind of like goes back to is Brontosaurus and Apatosaurus, are they the same thing, are they different things? Nobody agrees. So it basically has to do with looking at little variations on the skeleton and kind of comparing those to other skeletons and how it all jives together. It's probably not the best description, but it's kind of like a big cage match.
When did they quit digging on the fossil wall?
So the original excavations ended in 1924. There was a pause until the 1950s. They removed some overburden, they removed rock. And then in the 1950s, the work on the actual quarry regenerated and started again. And then they worked consistently on the quarry wall from the 1950s until the 1990s. And so if you come to the quarry today, it might be much quieter than what it would have been if you came mid-1990s, because they aren't up there anymore with air scribes cleaning on the wall. So it's a little quieter experience than it used to be.
So I was just wondering, so we've got this big wall, are there other dinosaur sites within the monument?
So many. We have like 400 sites. We're really lucky. And that's not even that many. I mean, like, I think about where I worked in San Juan County and Grand County, where we had over 1,000 in each of those counties. But for a little small area with honestly just a little bit of Mesozoic outcrop, we're doing pretty good. So yeah, we have a lot of different Jurassic quarries, but we also have quarries in the early Cretaceous. We've had things from the Triassic, and then of course, if you want to get down into Paleozoic, we even have some stuff down there as well.
Do you have an opinion you can say on this site out in South Dakota where the guy's waiting in that house?
Oh, the Tana site?
Yes.
What kind of opinion are you looking for?
Do you think his argument's valid, or?
It's hard to say because the land's so restricted. Not enough people can go in to validate all the different things that are being said. So I think once more people are allowed to look at it from various different angles, we'll be able to have a better opinion of it. There also needs to be a lot more published. Supposedly a lot of that stuff is in the tubes to be coming out. So it's kind of a waiting game. I think they got a little ahead of themselves on some of the cooler things, like talking a lot before you have a chance to actually like have some concrete evidence. But they say it's coming, so it's always a waiting game in paleo. Our fossils have been dead a long time, so we often end up waiting a long time for results. But we'll see.
So if we are walking around and we find a fossil, are we allowed to keep it or do we have to turn it in?
That is a great question. So if you come to Dinosaur National Monument and you find a fossil, we ask that you leave it there. And you can tell, you can always reach out to me, the paleontologist. My email address was at the beginning of the talk. You can always reach out to our interpretive staff or anyone at our visitor centers and say, hey, I found something. And we actually have a form that you can fill out that kind of tells us where you found it. You can email us pictures, kind of give us a description of where the area is. Or if myself or any of my staff are around, we're always happy to run out there with you to look at stuff, because it's really important to see it in the ground, in the context where it's found. So that's what we ask. And of course, in anytime you're visiting national park land, we ask you not to pick anything up, whether it's a flower or a rock or an eagle feather or something like that. It's always good to leave that stuff in place. Now that said, if you're on other public lands, like if you're on BLM land or Forest Service land, if you found an Elrathia trilobite in the West Desert, you can collect that if it's off public land and you're just going to take it home to keep for yourself. You can't sell it, but you can take it home to keep it for yourself for, cool collectible. If you found a dinosaur down in Grand Staircase that's BLM land, you can't take that home. You need to leave it there. I think you could reach out to somebody like Natalie or Randy or Carrie or somebody, and they can tell you how to better report that fossil so that then they can go out and look at it in the field. But yeah, you guys are our eyes and ears out in the field. You were the ones hiking around and seeing way more than we could ever do. We've got so many balls that we're juggling, whether it's being in the lab or the office or the field, that we can't be everywhere. So we love to hear from you guys and have you guys tell us about the finds you found, because otherwise we wouldn't know about a lot of stuff. So we really appreciate you guys reaching out to us.